Hello and welcome to another Ginger Mathematician video. So today we're doing a big deep dive into binomial distribution. This is for A-level Maths Stats 1 or Paper 5 as it's also known. So making sure you're ready to do any binomial question that appears. Now we will be dipping into normal distribution as well. So the following things we do need to be aware of to work out the expected value and variance of DRVs. We're going to talk about that in a separate video in more depth, but still important knowledge. And then binomial distribution, so how we work out specific probabilities with a binomial distribution, and the mean and variance, which will be important in the very first question because we also need to work with these normal distribution tables. Again, in the very first question, I'll show you how binomial and normal distribution interact. So most of these questions will be binomial distribution, but I will dip into other topics. Right, let's get started. So in Greenton here, 70% of adults own a car. So the probability of owning is 0.7. And our random sample here of 8 adults, so our n here is going to be equal to 8, from Greenton is chosen. And now we need to work out the probability, the number of adults in the sample who own a car is less than 6. So how do we write this in mathematical notation and then use the tools that we have? Well, we then know that x is binomially distributed because we have the number of trials, which is 8, and the probability of success, which is owning a car here, is 0.7. And we want to work out the probability of owning a car is less than 6. Now, doing less than 6 directly does take quite a bit of time. It's only a 3-mark question because we'd have to work out the probability of 0, 1, 2, 3, 4, and 5. What's easier to work out is actually doing 1 minus the probability of 6 owning plus the probability of 7 owning, and then probability of all people in the sample owning 1. Notice we've only got 3 calculations then that we have to work out, and it really speeds you up on this paper, and this paper is really tight on time. Now, how do we work out the probability of 6 actually having a car? Well, this is where that formula comes in that we looked at before. So if we go to this formula here, we want to work out P6. So we're going to do HU6. Again, I'll show you on the calculator exactly what to click. And then we want the probability of success, which was 0.7 in this case, would be then to the power of 6. These two numbers are the same. And then the against probability here, so 0.3. And then these two numbers have to add up to 8, so this has to be 2. So we're going to be using that formula and applying it 3 times so we can work out those probabilities separately. So let's go to the question. So we have 8 choose 6. And we have 0.7 to the power of 6, 0.3 to the power of 2. Then we want to add together 8 choose 7. So 0.7 to the power of 7, 0.3 to the power of 1. And then finally 8 choose 8, which is just 1, but we can still write it in, is 0.7 to the power of 8. And anything to the power of 0 is 1, so we don't have to worry about that too much. Now, the question is, how do we write this into the calculator reliably, making sure we've got the timeses and pluses in the right place? Let's go and do that now. So I've got a normal class whiz calculator, nothing too special. So it should work for most of your calculators out there in the world. So we have 1 minus, deep breath, we can do this. So we have 8 choose 6. So we go 8, shift, and the C button down here. So 8 choose 6 times 0.7 to the power of 6 times 0.3 to the power of 2. And now we do plus, not over there though. That would be a strange place to put it. There we are. So plus, right, 8 choose 7. So C7 times 0.7 to the power of 7 times 0.3 to the power of 1. Make sure you put the pluses in the right place. That's the hardest thing to remember. And then with 8 choose 8, again, I'll just do that. You don't have to put that in there. And then 0.7 to the power of 8. Close our bracket. Press the equals button. And then we get our answer as 0.4482. 0.4482 dot dot dot, and so we'd round this then to 0.448. Again, you can see in the answer Again, wouldn't recommend the alternative method. This is a much quicker way to get 3 marks here. Now, going straight into a pretty tricky question right off the bat here, which is a random sample of 120 adults is now chosen. Now, sometimes they'll actually get you to justify why we're using the approximation. Again, we'll talk about that in a later question. But here we just need to use the approximation to find the probability that more than 75 of them own a car. 5-mark question is going to require quite a bit of work. First thing we want to do is work out the mean. So again, we often use this symbol mu. Again, and we've got the variance as well. So be familiar with these signs, and we're going to work out both here. Okay, so to work out mean, again, we've got our formulae here. We're going to do n times p. So np, and then variance is np times 1 minus p. Now, what does that actually mean for this question? So our sample size is 120, so we have 120 times the success, which was 0.7. And here we have 120 times 0.7 times 1 minus p, so 1 minus 0.7, which is 0.3. So we can use the calculator here just to quickly work those things out. So 120 times 0.7 is 84. Again, in this kind of paper, it's best just use your calculator to do any of these things, and here we just times it by 0.3, so we get 25.2. Okay, so we then know that it's going to be normally distributed. So as soon as you see approximation with binomial question, we're going to use the normal distribution as an approximation of the binomial distribution. So we have, let's just call this y now, is normally distributed with a mean of 84 and a variance of 25.2. Okay, and we want to work out the probability of x, or y in this case now, is more than 75. Okay, more than makes it a little bit more tricky, but it's fine. So this is where we're going to work out a z-score, or a z-value. Again, if you're not sure about this process, you can either watch my normal distribution video, I'll do a deep dive at some point, or you can just watch the section from my all of paper 5 video, how we do this. But to convert this to a z-score, and basically what we need to do, so I'll use z now, is we minus, I'll talk about the 75 bit in a moment, minus the mean, and then divide by the standard deviation. Notice here this is the variance, not standard deviation. So the standard deviation is just the square root of this, so the root of 25.2. Okay, now we can't take 75 directly because we have to consider the so-called continuity error, so the rounding that goes to 75. So I'm going to take 75.5, the upper bound essentially here. So we need to make sure we do this continuity correction when we work out the z-score. So if I actually work this out, and we'll find out what z-score that we have to work with. It's going to be negative because you can see 75.5 minus 84. But again, we can deal with that in a moment. That's not a problem. So we put it in. So 75.5 minus 84 divided by the square root of 25.2. And this gives us minus 1.693. Okay, so essentially here we're looking for z being greater than minus 1.693. Okay, that's fine, we can deal with. Now we've got a greater than sign and we've got a negative, so they kind of, bad maths, cancel each other out, but essentially it would be 1 minus, if I wrote this out properly, z less than 1.693, and to change the minus we do 1 minus again, so we do 1 minus probability of z is less than 1.693, which has the effect of these cancelling, and so what we actually need to work out here is actually 1.693 on our normal distribution table. So if you're not used to your normal distribution tables, let's go and do that now. So here's our distribution table, and we're looking for phi of 1.693. Now how do we do that? First of all, we go to 1.6, Then we go to the 9 and find out that number, so that's 0.9545. And now we've got the 3, so we add an extra 3 to the last digit, so that gives us 0.9548. So the answer here is 0.9548, and that's going to round then to 0.955. So that's the probability, almost certain, yeah? Because we've got a probability very, very close to 1. And that gives us our final answer here for the 5 marks. The reason it's such a big question, like relative to other questions on here, is you have to do the mean and variance first. Don't forget the continuity correction, otherwise you get a slight error if you do not do that. Using the standard deviation down here. And then working out this phi here, when we have a greater than sign and a negative. So we do 1 minus and then 1 minus again. So essentially we work out just phi of 1.693. That takes quite a lot of understanding here to get the 5 marks. Okay, so if you found that question just completely overwhelming, which I understand completely, again, that was a hard question to really get you into this, and now we can look at some slightly easier questions. Okay, and on to our next question here. So, in a mysterious certain country here, the probability of more than 10 centimeters of rain on any particular day is 0.18, independently of the weather on any other day. Okay, that's really important. As soon as we see independent, then we can generally start using binomial ideas here and find the probability that in any randomly chosen 7-day period, okay, so 7-day period, so n is equal to 7, more than 2 days have more than 10 centimeters of rain. So again, we set this up binomially. So we have 7 days in the week in order to use, and if it rains, it's more than 10 centimeters of rain, that's going to be 0.18. And we want to work out the probability that x is greater than 2, more than 2 days. Okay, so again, we can think about it, which end we want to go, negatively or positively. And I think it's much easier again to work out 1 minus the probability of no day of more than 10 rain, only 1 with more than 10 centimeters of rain, and 2 days with more than 10 centimeters of rain. So generally in the first part of the question, they give you some sort of fairly standard binomial process to do here. So again, we do this in exactly the same way as we did the previous question. So the first one is no days where there are more than 10 centimeters of rain. So that gives us then 7 choose 0. The probability of rain is 0.18 to the power of 0, which is just 1. And then we have 0.82 to the power of 7. And then we have 7 choose 1. 0.18 to the power of 1, 0.82 to the power of 6, and then finally 7 choose 2, 0.18 all squared times 0.82 to the power of 5. So it's easy enough to write this out, it's just being very careful on the calculator how we do this. So let's have another go at this. So we've got 1 minus, and then let's go. So 7 choose 0 is just 1 anyway, but let's just do this as I've written it out. So 7 choose 0. 0.18 to the power of 0 is 1. So 0.82 to the power of 7 plus 7 choose 1 times 0.18 times 0.82 to the power of 6 plus 7 choose 2 times 0. Hope you're quicker at home at doing this than I am. Again, expecting a big skip of the video at this point. 8 to the power of 5, close brackets, press equal 0.115, dot. Cool, yeah, and they're happy with just 0.115. Yeah, 3 significant figures makes a lot of sense. So again, very similar to what we did so far. Usually the part A is something like this. Work out a very specific probability, greater than, less than something. Part B is where it gets a bit trickier. So for 3 randomly chosen 7-day periods, find the probability that exactly 2 of these periods have at least one day with more than 10 centimeters of rain. Okay, that's quite overwhelming. I would ignore the first part, the 3 randomly chosen 7-day periods and the exactly 2 bit. We'll come to this next. Let's just focus on the probability of at least one day with more than 10 centimeters of rain. Okay, so at least one day out of the 7. The easiest way to work this out is 1 minus the probability of no day with more than 10 centimeters of rain. Okay, so again, using that reversal idea. So no day with more than 10 centimeters of rain. So on one particular day, it's 0.82, and there are 7 days, and there's only one way of doing it, is having Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, all with no more than 10 centimeters of rain. So there's no choose needed here. I mean, you could do 7 choose 0, 7 choose 7, but it's not required. It still just gives you one. There's only one possibility. So if we work this out, so 1 minus, I'll show you how we use that result afterwards. So we have 1 minus 0.82 to the power of 7, and that gives us 0.7507, which is ends approximately 0.751. Okay, so that tells us the probability of at least one day with more than 10 centimeters of rain, 0.751. And now think about this like a tree diagram. And if you ever get stuck, tree diagrams are usually quite useful. So think of this, again, I'm not going to do the entire thing out here, but just to give you a view of what's going on. And you don't need to do this in the exam. Imagine we've got like day 1, day 2, and day 3. And we either have, at least one day of more than 10 centimeters of rain, or we don't have one. So we're turning it into a binomial. Either we have at least one day of more than 10 centimeters of rain or not. So we've got AL for at least and then not at least. So at least one day we have 0.751. And then the opposite of that, what would that be? 0.249. Again, you can check on the calculator because these have to essentially add up to 1. And notice this doesn't change from day 1 to day 2. Each day is independent. So this would be 0.751. This would be 0.249. You see the pattern here across all the tree diagram that we have. And we want exactly 2 of these periods to have at least one day of more than 10 centimeters of rain. So we want either at least exactly 2. So this one, this one, this one. So this root, or this root, this root, this root, or this root, this root, this root, because that gives us exactly 2. So notice if I work this one out, it would be 0.751 times 0.751 times 0.249 to work out at least one day, not at least one day. But notice it would be the same probabilities for this root and this root. So in order to work out the answer to the question, so exactly 2, we take the answer that we have here, so 0.751, or squared, because we times it by itself, times 0.249, and because we've got 3 possible roots of this, we then times by 3. So if we put this into the calculator, so we can just leave the answer here, can't we? So we have squared times 0.249 times 3. This gives us 0.42098, which then rounds to 0.421 to answer our question here, to give us the answer there. So an interesting question. You're using the binomial distribution at the start, but then it now turns into a more tree diagram-esque question. This is where you have to be very careful with binomial distribution questions. Again, it can dip into other parts of the course. The first question we just looked at was a normal distribution style question, and here we're now dipping into a sort of pure probability style question. Okay, and on to question 3 here. So 80% of the residents of Kinwara are in favour of a leisure centre being built in their town, so a probability of success, so building leisure centre is 0.8, and 20 residents are being chosen at random, so n is 20, and whether they're in favour. Find the probability that more than 17 of these residents are in favour of the leisure centre. So that means we are binomially distributed here with probability of 20 and then the probability of 0.8, and we want to find x to be greater than 17. Now here we don't actually have to do the 1 minus flipping here. All we need to do is work out then the probability of x equals 18, x equals 19, and x equals 20. So this is one where the flip is not required. We just work out 18, 19, 20 separately and then add them together. So what does that look like? Well, we have 20 choose 18, 20 coming from our residents we are asking, and then we have 0.8 to the power of 18, 0.2 squared, and then 20 choose 19, 0.8 to the power of 19, 0.2 to the power of 1, and then 20 choose 20, 0.8 to the power of 20. So let's go to my calculator and work this out. So we have 20 choose 18 times 0.8 to the power of 18 times 0.2 squared. Key thing with this is just be patient, work your way through. If you want to, you can skip the video or you can keep me company as I pop this in. I seem to say the phrase pop this in quite often. Times 0.2 plus, and the 22 20 is just 1, so we can just go 0.8 to the power of 20. That gives the answer of 0.206 equals 0.2060, which rounds to 0.206. Again, you can see you've got the two choices. Again, this is the far easier way of doing this. As you see, as you're getting quicker at these kind of questions, you can speed through this and give yourself a little bit more time for some of the more difficult questions towards the end, those permutation, combinations, and normal distribution questions. Now, part B, find the probability that the fifth person asked is the first person who is not in favour of the leisure centre. So I'm going to use yes for in favour and no for not in favour. So the only way this works is yes, 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 and then the next person being no. So we know the probability of yes is just 0.8. So you have 0.8 times 0.8. You get the idea here, times 0.8 times 0.2. Of course, we can tidy this up. And there's only one way of doing this, yeah? Because the fifth person has to be the first person not in favour. So we have 0.8 to the power of 4 times 0.2. A 1-mark question shouldn't be more complicated than this. And if we pop this in the calculator, to the power of 4 times 0.2, we get the answer of 0.08192. And with this kind of thing, I would just leave it as that. I don't think I would try rounding at this point. Yep, and they agree. Again, just an exact value, I think, is the easiest way to go about it. Now, that's not too tricky a question, although this one takes a bit more thinking about. So find the probability that the seventh person asked is the second person who's not in favour of the leisure centre. Okay, so let's do one example of this. Imagine the first person is not in favour. Then everybody else afterwards is yes. So yes, 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 yes. And now the seventh person is a no. So this is one possibility of the way that we could do this. Alternatively, we have a yes first and then the no. Then we have all the yeses. And then we have the no. This one has to be the second n that exists. Now you can probably see the pattern here. We could have next two being yeses, then a no, and then yes, 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 no. And if we go through this way of doing it, how many different possibilities do we have? Well, we have 1, 2, 3, 4, 5, 6. So because the probabilities are independent here, it's always 0.8 and 0.2, we can work out one of them. So we can work out this as 0.8 to the power of 5, because we've got 5 yeses, 2 no's, so 0.2 squared, and we have 6 different ways of doing this. A tree diagram, yeah, I suppose you could do that as well, but I think just writing out as a quick list here and seeing the pattern makes this question a whole lot easier. So the key thing is actually working out this 6 and realizing there are 6 ways in which this can be done. Once we have this, then we can just put this into the calculator. So 0.8 to the power of 5 times 0.2 squared times 6. I did the arrow thing again. Oh no. There we are. And we get the answer of 0.0786432. 0.0786432. Again, would I keep that as a whole number? Probably, I guess. And they've rounded to 3SF, which makes sense. Yeah. So 786 to 3SF. 3 significant figures. So nice question. Again, binomial distribution starting, just like we've seen in the previous questions before, but then goes now into your understanding of probability again as well. So you really have to be quite adaptable. Okay, and if you had horror stories about that very first question that we've done in this video, this is the time to redeem yourself. This is very, very similar. So in Kvesta, we have 60% of the adults travel to work by car. So P is equal to 0.6, and our sample size here is 12, so N is equal to 12. And we want to find the probability that the number who travel to work by car is less than 10. Okay, so again, X is binomially distributed, sample size of 12, and probability of 0.6, and we want to work out X is less than 10. So this is one we do need to flip around, so we have 1 minus, and then the probability, we want less than 10, so we need X is 10, X plus X is 11, and X is 12. I imagine you're getting very quick at doing this now at home, so let's just write this out very quickly. Again, pretty used to this now. So 12 choose 10, and we have 0.6 to the power of 10, 0.4 squared, 12 choose 11, 0.6 to the power of 11, 0.4, and then 12 choose 12, which is just 1, 0.6 to the power of 12. Okay, so we've got everything written down for the examiner, so they are very happy. Let's just pop this in. So we have 1 minus, and then we have 12, choose 10. Hopefully this is a confidence boost as well, yeah? So you can definitely pick up marks on this paper. It's not as bad as maybe some students kind of think, because so much time gets spent on pure 1 and pure 2 and pure 3, depending which order you're working in. It's important to not ignore the stats that you have as well, because it can be an easy module to get. Yeah, it may be compared to mechanics possibly. Maybe it's a bit harder. 12 choose 12 is 1, so I can just write 0.6 to the power of 12, close my bracket, and 0.9165. Good. 0.9165 dot dot dot. So 0.917, and that gives us the 3 marks here as well. So you really need to sort of bash through these questions so you have more time for the next part. And it's the approximation question. So we have a random sample of 150 adults from Kvesta is taken. So we got 150. Use an approximation to find the probability that the number who travel to work by car is less than 81. Okay, so approximation, as soon as we see this, we're going to have to do a normal distribution. And before we can use that, we need to work out the mean and the variance. So the mean here being MP, and the variance being MP 1 minus P. So we have 150 times, what was our probability? 0.6. And we have 150 times 0.6 times 0.4. So let's work out those values. Again, you'll get some marks just for working out this part before doing anything else. The continuity correction and the rest of it. So we have 90 for here. And we times this by 0.4. giving us 30. Oh, that's a nice number for the standard deviation. So it means this standard deviation here is going to be 6 because it's the square root of 36. So that's kind of useful. Okay, so let's just use a y here, and now we're going to be normally distributed with a mean of 90 and a variance of 36. And now we need to do our z-score. Okay, so we've got the probability and we're looking for y to be less than 81, and now we convert it into a z-score. So we're going to need to think about our continuity correction. That's less than 81, so let's go with 80.5, so our lower bound, minus the mean, so that's minus 90, divided by the standard deviation, which is 6. Okay, so let's work out what our z-score looks like. It's going to be negative again, but it's less than, so that's going to make things probably a little bit easier. So fraction button, 80.5 minus 90 divided by 6 gives us minus 1.583. 5833, yeah, dot, 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 dot. Okay, so we've got less than and minus. So if we've got the phi of minus 1.5833, so the way to work that out, because it doesn't have negatives within our table, we do 1 minus the positive version. Now, because we've got a less than sign, we don't have to flip twice, so we just have 1.5833. Okay, so let's see if we can work that out on our table. So 1.5833. Let's see what that looks like. Let's use a different color. So 1.5, that one here. 8, so that's here. And then we want 3, so we add 4 to it, so 0.9433. Okay, so let's go back to three. Okay, and then we just take that away. So 1 minus 0.433, and that gives us 0.0567. I hope there's no rounding error here. No, 0.0567. They are happy with that. That's nice to give us our 5 marks for this question. Give myself a little bit extra room here in order to do the working, but I managed to fit it all into here. And part C, so justify the use of your approximation in part B. So essentially what we think about here is so-called MP and M brackets 1 minus P. So we should always check that. So what's our sample size here? It was 150, yeah. So MP was 150 times 0.6. It was what the mean was, yeah? So that's it. So it's equal to 90. And M brackets 1 minus P, or NQ, this is sometimes known, 150 times 0.4. Oh, I should probably just use a calculator for this. But yeah, you need to show both MP and NQ, and particularly when the probabilities are quite close, then usually it's no problem, but you still need to check for the examiner. So that gives 60. And the key thing to look out for here, so 90 and 60, they're both greater than 5, therefore use of approximation is appropriate. So just checking MP and NQ are both greater than 5. Okay, so that's something that wasn't in the previous question. Occasionally, as you see, they give that as a 1 mark question to see if you just appreciate why we use normal distribution to estimate or approximate a normal distribution. Okay, so I'm going to stop the video at this point. There are more questions here in the PowerPoint that I'm not going to go through in this particular video, but if you want to have a go, then click on the presentation in the description and you can have a go at these questions yourself, and then you can check the answers as well. You'll see the answers are down there. Again, you've seen most of the kind of questions here. for binomial distributions. So if you're familiar with the content in this video, then you should do very, very well in your paper 5 exam.